So this is the numerical, and we will try to plot the shear force and bending moment. Now first of all, you know very well, we have to determine the reactions. How to determine the reactions? We have to apply the equations of equilibrium. So equations of equilibrium, summation of vertical forces Fy will be equal to 0, assuming that the upward forces will be positive and downward forces will be negative. So please apply here this equation of equilibrium, and you abbreviate this reaction as Ra, this as Rb. So these are the two reactions. So upward force Ra, and this is one more upward force plus Rb. So Ra plus Rb. Then only vertical forces you have to see, there are no horizontal forces. So this is in downward direction, minus 15, and this is again in downward direction, minus 20, equals to 0. So Ra plus Rb, you will get Ra plus Rb will be equal to, this will move to right hand side, 35. So this is your equation number 1. Next equation of equilibrium is summation of all the forces, summation of moments because of all the forces acting on any point. Either you can take moment about A, C, D, B, any point. I am taking about A, will be equal to 0 if the body is in equilibrium. Sum of moments because of all the forces about any point will be equal to 0. Second equation of equilibrium, considering clockwise moments as positive and anti-clockwise moments as negative. So if we will apply here at point A, Ra will give no moment because it is itself passing through point A, no lever arm is there, so it will be equal to 0. See this 15, you assume that your forces are in kilonewton and your distances are in meters. So kilonewtons and meters are the units which we are following. Now you turn your pen, move your pen in the direction of the force about point A, because you want to determine the moment about point A. So see now, you have to move your pen in copy, or if you are sitting on computer, you have to move your pen or cursor in the direction of force about point A. So this is clockwise moment. So clockwise moment we are considering positive. So it is positive. 15 multiplied by 2, that is 30. Then this is one more vertical force, 20. You move again your pen in the direction of force. This is the downward direction of the force about point A, and see how is the movement. Again it is clockwise. So clockwise we are considering positive. Moment is equal to force, 20 into distance, 3 into 2 is 5. So 20 multiplied by 5 will be the moment because of this load 20. Then this is one more vertical force. Now this time you try to move the pen or cursor in the direction of force. Rb is upward, So in the direction of force about point A, how is the movement? See, this is anti-clockwise. So anti-clockwise we are considering negative. Force is RB multiplied by the distance. Distance is 7 that is equal to 0. In this way you can calculate the reaction RB. So please calculate and tell me, students. This will be 30 plus 100, 130. This will move to the right hand side. So 130 divided by 7. How much it is coming? 18.58. 18.58. Everyone is getting this positive value 18.58. Yes.
Yes, sir. Yes, sir.
Now positive value indicates that the assumed direction of reaction RB is okay, upward direction. Now you substitute this in equation number 1, you will get the value of RA. You will get the value of RA. So RA will be equal to 35 minus 18.58. How much you are getting? 35 minus 18.58, 16.42. Is it so? So 16.42 kilonewtons will be the value of RA, and this reaction again is positive. So the assumed direction, upward direction, is correct one. Now we have calculated these reactions. So write down here now how much is RB, and the value of RA also you note down. Let me clean the board. So remember, students, we are applying here the equations of equilibrium. Unless and until inclined forces will not act on a beam, you will not have to apply the equilibrium equation for summation of Fx, all horizontal forces equal to 0. No. So in this way you have obtained RA and RB. So you note down now, show in here figure. This RB is 18.58 kilonewtons. Remember well, all units are in kilonewton and meter. And RA you are getting again positive, upward direction, assumed direction is correct one. If it would have been negative in any other case, you can watch my video, one in case of a moment or couple. If you are getting negative here, then you have to change the direction of the reaction. So this is 16.42. 16.42. So in this way you have calculated the reactive forces using equations of equilibrium, and you have shown in your figure. Now you have to use the section method. You have to take the sections and you have to draw or plot the shear force and bending moment diagram. So let us start with, so first of all you assume section, this you assume this is section, suppose XX. Obviously to the left of the section one reactive force is there, so you have to assume at a distance x. Now sign convention, you can watch my previous videos. In all the lectures we have considered section left, section right, shear force to the left side of the section upward positive and downward negative. To the right side we have vice versa, upward shear force negative we are considering and downwards we are considering positive. So this is the sign convention for shear force. Now try to develop the master equation. So this I will mention here x1. So shear force V x1 will be equal to section left. We are considering only one force is there, section left upward positive, so 16.42, and that will be positive. This section will move from A to C. These are the extreme conditions. If the section will move at A, x will be equal to 0. If it will move, you can watch my previous videos, in that I have explained how the extreme conditions and values to be put. So if this section will move at C, x will be equal to 2. So from this master equation, which doesn't contain any variable x, so you can easily calculate the shear forces. Shear force at A is equal to 16.42. This is 16.42. Shear force at C equal to again 16.42, because you cannot substitute value 2 anywhere in this master equation because you don't have any variable x here. So the same value 16.42. So in this way you have calculated the shear force. Then next section you have to take in this span CD. So this is x2 and this is x2. You can take the section from left side or right side, it will not make any difference, because to the left of the section there are two forces, vertical forces. To the right of that also there are two forces. So anyway, as we are considering the sections from left hand side, again we will consider this section also from left hand side. So x to x2 is also at a distance x from end A. So your master equation here will be shear force x2. So this shear force x2 will be equal to, first of all you check this 16.42, section left upward positive, so it is 16.42. In shear force equation you have to consider only the forces. When we will develop the equation for moments, you have to multiply by the lever arm and distance. Then next is this in downward direction. To the left of x2 this force is there. So section left downward minus, so it will be minus 15. Your section is valid from C to D. At point C, if your section is here at point C, this x value will be equal to 2. And if this section will be at D, this x value will increase, and at D it will be equal to 2 plus 3, because this section is at distance x from A. So when it will move x2 at C, you have to see that at what distance it is from A. It is 2 meters from A when it will be at C. When it will be at D, it will be at 5 meters from A. Now you try to calculate the values for shear forces. Shear force at C, you have to calculate. Shear force at D, you have to calculate. Now you look at this equation, 16.42 minus 15, it is coming 1.42. So we cannot substitute the values 2 and 5 in this equation, there is no x variable. So shear force at C will be equal to 1.42 and shear force at D will also be equal to 1.42. Now you try to develop the third master equation, and for that you assume the section x3 this x3 will be at a distance x from B. Now this time I am considering right hand side, because left hand side if I will consider, I have to deal with 1, 2, 3 forces, vertical forces. So right hand side only one vertical force is there. So I am developing the equation for the shear force x3 equals to the right side upward force is there. So right side upward force is negative. So it is minus 18.58. This is minus, sorry, I will erase this. It is minus 18.58 minus 18.58. So I will now try to again calculate this x3, this is the section valid from, I am taking from right hand side from B, so it is valid from B to D. If the section will be at B, x will be equal to 0. If it will be at D, x will be equal to 2. So you can easily calculate the values as shear force at B. Shear force at B will be equal to minus 18.58 and shear force, if you will calculate at D, shear force at D will be equal to minus 18.58. Now all the values of shear forces are available. You have to plot the shear force diagram here. This is your point A, this is your point C, this is your point D, and this is your point B. Upward positive values will be plotted upward, negative values will be plotted downward. This is my sign convention, you can change also. So start with this. Shear force is 16.42 positive, so you will plot here and you will write here this value is 16.42. all values are in kilonewton. You can mention here 16.42 kilonewtons also, or below you can mention that all units are in kilonewtons and meters. Then at point C the same value is there, so 16.42 is again same value, so 16.42 it is same. So this is your value C. Then you have VC 1.42 from master equation. So see now, this is 1.42 from this equation at C. So from C 1.42 means here, right? This is 1.42, this value. So now this value is 1.42 and same value at D also. So this will continue like this. This value here will also be equal to obviously 1.42. So I am trying to use different colors, right? So this was the shear force diagram because of this equation. This black color I have drawn from this equation number 2, right? And now from third equation, whatever the values we have opted, I shall use one more different color. So at B it is minus 18.58. So minus 18.58. See, when you draw the freehand sketch, try to proportionate it. See, this is 16, you have shown this much distance. So slightly more than that, and negativities, so you have to plot below. So it is 18.58. And at D also it is minus 18.58. So like this you have to plot. Now I have used this blue color for plotting the values obtained from the third equation. So this is from the third equation. These values are positive values. So in this way we can plot the shear force diagram. So I think plotting the shear force diagram, you might have enjoyed, understood the concepts. And as per the sign conventions are concerned, if someone is plotting positive values below this, then you will get mirror of this. This will be below the x-axis, this value will be above the x-axis, but the solution will not make any difference. So in my next lecture, the same problem we shall take, simply supported beam with 2-point loads, and we shall try to plot the bending moment. Okay, thank you students, thank you.